Venus is the second planet from our Sun, and is often called Earth's twin because they're similar in size, and they were formed at the exact same time by material from the solar dust cloud that existed 4.5 billion years ago. But how did Venus end up in a toxic world while Earth survived and gave life to our planet? Here on Space Hut, come with me on this journey where we solve the mysteries of why Venus is known as Earth's evil twin, and what specific time period that caused Venus to become a hot, hostile, lifeless planet. So come with me on part 1 tomorrow. What's up, everyone? Welcome to Space Hut. This is the first official episode to Earth's evil twin. So how is Venus different from Earth, and how hot is this planet? Venus is very different from Earth. It has no ocean and is surrounded by a heavy atmosphere composed of mainly carbon dioxide, with virtually no water vapor, and its clouds are composed of sulfuric acid droplets. At the surface, the atmospheric pressure is 92 times down on Earth's sea level. Venus is a scorched planet with a surface temperature of about 482 degrees Celsius, or about 900 degrees Fahrenheit. The high temperature is primarily due to a runaway greenhouse effect that's caused by a heavy atmosphere of carbon dioxide. Sunlight that passes through the atmosphere to heat the surface of the planet. Heat rays radiated out, but it's trapped by the dense atmosphere and not allowed to escape. That makes Venus hotter than Mercury. What's up, everyone? Welcome to Space Hut. This is part 2 of Earth's evil twin. Without further ado, let's get started. And this is the formation of Venus. So 4.5 billion years ago, our sun was surrounded by a cloud of gas and dust called a nebula. As the sun got bigger, the gravity collapsed the cloud into a disk of all this material, and it took 50 million years for the sun to fully form. As the sun's luminosity increased, it got hotter. It pushed the gases outward to form the gas giants, and leaving behind the dust and rock. Like Earth, the dust had clumped together to form the planets. As it got bigger, it started to have its own gravitational pull to attract bigger objects. The process took 15 to 20 million years for Venus and Earth to fully form to their present size. So that's pretty much how Venus formed. What's up, everyone? Welcome to Space Hut. This is part 3 of Earth's evil twin. Without further ado, let's get started. So astronomers have been asking this question for a long time. Why is Venus spinning in the wrong direction, and why is Venus so slow? So Venus rotates backwards compared with the other planets. It's likely due to an early asteroid which disturbed the original rotation. It's a spherical object between 500 to 1,000 miles wide that hit Venus. The energy from the colliding object had heated the upper mantle enough to melt it. That melted portion would have risen the surface temperature, but spreading into a long, shallow layer beneath the crust. Water and carbon dioxide with the mantle could have been released to surface as gases, which have caused a significant shift in the planet's atmosphere. This collision happened about 3 billion years ago. Also, the reason why Venus is so slow is because the gases are so thick, it's causing friction against the surface, causing the planet to slow down. What's up, everyone? Welcome to Space Hut. This is part 4 of Earth's evil twin. Without further ado, let's get started. So what was early Venus like before turning into a dry, hot planet? So Venus most likely had been Earth-like climate. According to recent climate modeling, much of its history, Venus had a surface temperature similar to present-day Earth. It was likely to have oceans, rain, and perhaps snow. Maybe continent and plate tectonics were even there. Even more spectacularly, perhaps the surface life. But also a shallow liquid ocean and habitable surface temperature up to 2 billion years of its early history. What's up, everyone? Welcome to Space Hut. This is part 5 of Earth's evil twin. Without further ado, let's get started. So how did Venus lose all of its water, and how did the planet's temperatures pump up? And this is all because of a runaway greenhouse effect that occurs when a planet's atmosphere contains greenhouse gases and amount is sufficient to block thermal radiation from the planet, preventing the planet from cooling and having liquid water on its surface. This is all because Venus has so much carbon dioxide in its atmosphere, all because of volcanism. It didn't have time to recover. It didn't contain a layer to block all this, carbon dioxide from reaching parts of the atmosphere. So all of it didn't have time. So all this carbon dioxide just kept spewing. So all of a sudden, that light from the sun was trapping all that carbon dioxide and pushing the temperature on the surface very, very hot to about 900 degrees Fahrenheit. Well, specifically 860 degrees Fahrenheit. What's up, everyone? Welcome to Space Hut. This is part 6 of Earth's evil twin. I just want to do a quick message to you guys. I just want to say thank you so much for 16,000 followers. And this is why I just love doing this passion, because one day I want to become an astronomer and teach everyone else, about space and, my passion and what I do. That's why I'm here. Just why I'm teaching you guys all about space, because I just want to follow my passion. So without further ado, let's get started. So the atmosphere and surface of Venus. The atmosphere of Venus is mainly carbon dioxide with thick clouds of sulfuric acid and completely covering the planet. The atmosphere of Venus is composed of 96.5% carbon dioxide and 30.5% nitrogen and other traces of gases, known to be sulfur dioxide. So the surface of Venus is dominated by volcanic features as more volcanoes than any planet in our solar system. About 1,200 volcanoes active, and is covered in basaltic lava. If you ever get close to the surface, you get crushed and melted, and there's no way you're coming out. So yeah. What's up everyone, welcome to Space. So this is part 7 of Earth's Evil Twin. Without further ado, let's get started. So there's been past missions to Mars, and some of them landed on the surface of Venus, actually. So on December 15, 1970, an unnamed spacecraft, Venera 7, became the first spacecraft to land on another planet and measured temperatures of the atmosphere of Venus. By 1972, Venera 8 gathered atmospheric pressure and surface data for 50 minutes after landing. 1975, Venera 9 landed on the surface of Venus, and the Soviet Union between 1961 and 1984, they gathered information about the planet Venus, and due to the extreme surface conditions on Venus, the product can only survive for a short period on the surface, with times ranging from 23 minutes to 2 hours because of how hot the surface is. Like, it will really melt and crush it, and then all that sulfuric acid will just eat away at the material that the space probes and spacecrafts are made out of. What's up everyone, welcome to Space Up. This is part 8 and the final part of Earth's Evil Twin. Without further ado, let's get started. So without further ado, let's get started to the future missions to Venus. And this is a way to end off the series to Earth's Evil Twin and learning about more about Venus. So comment down below what other planet you want me to talk about in a new series. So without further ado, let's get started. So according to an official statement by the Veritas spacecraft that proposed a 2026 launch that will orbit Venus and peer through the planet's obscuring clouds with the help of a powerful radar system, to create a 3D global mapping system and near-infrared spectrometer to figure out what the surface of Venus really is made out of.